Today, we discuss the term 3 past year in 2022, question 20. X-rays are produced by accelerating electrons through a potential difference of 30.0 kilovolt towards a metal target. Explain the production of characteristic line spectrum and continuous spectrum in X-rays. So 5 marks. Okay, so let's go through the sample answer by me. So when the accelerating electrons collide with metal target atom, so there's loss in kinetic energy, which is converted into photon of a range of frequency. So this is how we get the continuous spectrum, okay, where the intensity varies with the wavelength of the photon without distinct gaps or lines. Okay, so this is just elaborate more so that to make sure we can get the full marks. Okay, so and then also can mention there's existence of minimum wavelength where all the kinetic energy is converted to photon in a single collision. Okay, if you recall about the graph, there is a minimum wavelength. And then next, there's also a sharp peaks of high intensity at certain wavelength. So this is the line spectrum. Okay, so this is where the inner shell electrons of the target atom are knocked out by the fast-moving electrons, and then the vacant shells are then refilled by electron from the outer shell and emits X-ray photon of specific wavelength. Okay, so those points are learned in the syllabus, do the revisions, and you should be able to answer this question. So next question, determine the shortest X-ray wavelength emitted. Okay, so this is what we have mentioned just now. And we have all the kinetic energy is converted to photon in the single collisions. Okay, but the kinetic energy of the electron is provided by the electrical energy. So we have EV equal to hc over lambda. So we have all the values given, some of them are provided in the constant variable. Okay, so you should get the answer is 4.14 times 10 to the negative 11 meter. So next question, by using the wavelength in B, X-ray beam produce a first order Bragg maximum at an angle of 7 degrees with the crystal planes. Determine the spacing of the crystal planes. So you need to recall back the concept. Okay, so this is the diagram that we have. So also can be related to the constructive interference, okay, where we have the path difference equal to the m lambda, okay, if we want to have the first order maximum. So the path difference here is the 2 of the delta L, which also the 2D sine theta. Okay, so we learned about the direction before. So put in all those values where m is equal to 1, first order, okay, m equal to 1. So you should be able to obtain the distance is 1.7 times 10 to the negative 10 meter. And then move to the last question. With the aid of a graph, compare the X-ray spectra if a higher potential difference is used. So this is also has been discussed in the slide. So this is the diagram that I have used in my video. So you can just go through it. So what we need here, okay, is that we have a higher potential difference. Okay, we look back at question B. If we have a higher V, okay, so since we know that the wavelength is inversely proportional to V, so a higher potential difference should give us a shorter minimum wavelength. Okay, so this should be on the left, okay, for the higher potential difference. Okay, and then we are requested with the X-ray spectra. So X-ray spectra should include the continuous and also the line spectrum. Okay, so at least we should include also the K series to obtain 4 marks. Okay, so I think that's how we can get the 4 marks in this question. So that's all for this question. Thank you.